As I mentioned, I went out and found just examples in tutorials and samples, sometimes in samples for completely unrelated technology, and just kind of pasted them all together to create a completely non-real messy starting point. The real messy starting points would typically be dozens and dozens of files here in Solution Explorer, tens of thousands of lines, and typically be wrapped around a technology that I don't necessarily want to talk about, like the DirectX SDK for graphics or how to calculate interest rates in a banking environment. So the demo doesn't do anything much, but it uses techniques that you may see elsewhere. And I'm actually going to unpin Solution Explorer so we have room for more code because there's only this one file. Let's start with strings. You can see here that this code declares an array called animals, and each entry in the array is a char string. This is deceptively simple because these are literal strings. If I wanted to actually, say, read the strings in from a file or read them in from input, I would have to get each string one at a time, probably into some sort of a temporary buffer, figure out how long it is, and then allocate memory out on the heap, the free store, to hold those strings, or say, well, your animals can be maximum 30 characters long, and I'll allocate 30 character element in the array to hold them, and if you happen to come up with a really long named animal, we're going to lose some of its information. That's actually the major problem with using char stars, is you have to do all this hand calculating about length. So here's some code that tries to glue all these strings together and print out the resulting string. As I say, the number one issue working with strings as char stars is you have to make room for them. So I have to know how long our total string is going to be. If I said that each element was 30 characters hard-coded, then I could say that 5 of them would be 150. But here what I'm going to do, this code is easy enough to find code just like it, is whip through the whole array, adding up the length of each string, and we intend to put spaces in between. So if we have a 5-character animal name like zebra, we then need a 6th character for the space after zebra. If we have a 3-character name like cow, we need a 4th character for the space after cow, and so on. And then something that trips up almost everybody, and if I was teaching you how to do char star strings, I'd spend more time on this. A char star string, after all of your letters, has what's called the null terminator, a character representing the end of the string. And you have to remember to allocate room for that, otherwise your string will be unterminated, and functions like printf will do very bad things. So once we've established the size, this code allocates a new character array out on the free store of that size. And because we're going to use some of the stir library functions, they find the end of strings using this null terminator. So we're going to put a null terminator at the very beginning of the string so that all those functions will work properly. And then I can run through again, concatenating with stircat each animal entry onto the all animals character string. That will put the null terminator in place properly, and also stircatting on a space, so there'll be a space between them. And this will then print out the animals. This code works. If I just run up to here, you can see that it does print out all of the animals with spaces between them. It's kind of a lot of work to achieve that, but it does work. If we continue down, you can also see a simple for loop that just loops through, printing them all out. Let's run down to that. Ignore the numbers for now. I'll talk about the numbers in a minute. There we're looping through the animals and printing them out. This code isn't broken. It's just old school. And what I'm going to do, the simplest thing to do, is to take my char star and turn it into a string. In order to do that, I'm going to need to include the string header. And I'll say using standard string so that I don't have to keep saying that over and over again. Because now each element of the array is a string rather than a char star, I can't pass it directly to these string functions like strlen. I have seen code that does this. the C underscore stir function gets a C style string from a string. This is a silly thing to do in many ways. You've gone to a lot of trouble. Well, okay, we typed 5 characters, but you've gone to some trouble to turn this into a modern string that you don't need to go to this with, and then you're turning it back into char stars. But, however, I'm going to show you it just because you may spot this and wonder why. Oh, I didn't need to do it to all animals because all animals is still a char star. Having done that, I'm going to now prove whether or not it still runs. So we'll start by building it and then run. We successfully printed out all the animals again, and then we'll run some more down to here. This is not so good. The call to printf says here, I'm going to give you a string in the old char star school of string that is null terminated. However, what it actually gets is this standard string. And as you can see, it compiles okay, but it doesn't run properly. And the fix for that is the same as the fix in the other loop, which is to add this call to cstir, just as a very temporary thing. If you're going to switch from char star to string, you don't want all of your code to break at once, so tossing in these occasional, oh, and give me the cstir out of that, will let you be a little more piecemeal about how you make your switch over. So now not only does it build, it also prints out the right values. This particular change from char star to string doesn't appear to have gained as much. I didn't get to rip out any code yet, but it sets the groundwork for what we'll do next.